For this second example, we haven't been given left and right limits. We've been given two functions, which if we graph, we can see that they intersect and define a very specific region. But we haven't been told what those left-hand and right-hand limits are. So we're going to have to find them out ourselves. So recall that we find the places where two graphs intersect by solving a system of equations. If y equals 2 minus x squared and y equals negative x, then I can write an equation 2 minus x squared equals negative x. So here's my equation, 2 minus x squared equals negative x. I can tell this is quadratic, so I'm going to put a 0 on one side, change the other side into standard form. I can factor. This is going to give me x minus 2 times x plus 1 is equal to 0, and I'm going to have two solutions, x equals positive 2, x equals negative 1. So I'm going to go back to this picture for a second. Just confirm, because you want to make sure, or at least in the right ballpark, would you believe that the x-coordinate of that place where those two graphs intersect is negative 1, and that the x-coordinate of this intersection is positive 2. So that kind of seems to match up. So now I know my left limit and my right limit. What I'm going to have to figure out next is my integrand. So if I were to, I'm just going to use this marker, and I'm going to trace along the top boundary of the region. So I'm going to start at the leftmost point, which is here, at x equals negative 1. And that didn't work. There we go. Trace the top boundary. And I'm going to stop when I get to x equals 2, which is the right-hand limit for this region, this area. So if that orange line I drew in was always along the same curve, that's a good start. So I think it was. I think everywhere I drew, I was drawing along the curve y equals 2 minus x squared. So that tells me that my top curve is 2 minus x squared. If I were to trace along the bottom curve, like the bottom boundary of this region, I'm going to start at my left limit and go toward my right limit. I think that whole time that I was tracing in purple, I was in fact tracing along that graph. So that tells me I always have the same curve on the top, it's 2 minus x squared. I always have the same curve on the bottom, that's y equals negative x. I know my left limit is x equals negative 1, and my right limit, x equals positive 2. So I can write my integral. So you can see here I'm going to integrate from left to right of top minus bottom. So my left limit, x equals negative 1, my right limit, x equals positive 2. The upper limit was that parabola, 2 minus x squared, and I'm going to subtract away the lower limit, which is negative x. So just be extra sure here. Both my top curve and my bottom curve were functions of x. I'm integrating with respect to x. And at negative 1 and positive 2 are x coordinates. They're specifically the leftmost x of the shaded in region and the rightmost x of the shaded in region. All right, so now I'm just going to integrate. I'm going to simplify that integrand, change that minus the negative x into a positive x, and just sort of rearrange this, which is totally optional, but I like to do it. Now I can find an antiderivative. The antiderivative of negative x squared is negative x cubed over 3. The antiderivative of x is x squared over 2. The antiderivative of 2 is 2x, and I'm going to evaluate that from negative 1 to 2. All right, so when I plug in 2, I'm going to get negative 8/3 plus 2 plus 4 minus the quantity negative 1 over 3 plus a half minus 2. And let's see what that comes out to. I've got negative 8/3 plus 6 minus 1/3 plus 1/2 minus 2. That's negative 8/3 plus 6 minus 1/3 minus 1/2 plus 2. I'm going to group together. Obviously, this part is not required on a free response problem, And you could have your very own method for simplifying here. So I'm going to say negative 8 thirds minus 1 third is negative 9 thirds. 6 plus 2 makes 8 minus a half. Negative 9 thirds is negative 3. Negative 3 plus 8 is 5 minus 1 half is 4 and 1 half, or 9.